Hey guys, welcome back to my channel. So in today's video, we are going to see another data analysis project, and the tool which we are using today is SQL, and the database which we'll be using is MS SQL Server, database, or we also call it as SSMS. And you can also use the same queries, just few twists will be required, and you can use it in MySQL also, as well as in PostgreSQL also, right? So in front of your screen, you can see I have used a few queries, and project which we are going to see today will be on Swiggy data, and this will be a real-time data for 3 months. I mean to say not 3 months, it will be for 3 quarters. And based on that, we will be doing some analysis with whatever problem statement or business requirement that we have. So this will be an advanced project where we will be writing multiple queries and do some data cleaning, create star schema, create generate joins, create dimension tables, create fact tables, and then at the end, after the star schema is generated, we will solve some business problems as well. So in front of your screen, you can see I have wrote many queries over here. To, let's say, for data cleaning, we are checking the null values, if there are any empty strings, incorrect data types, or if we have any duplicates, then how to delete those duplicates as well, right? So based on that, we will also create some schemas. So we can see we are creating here dimension tables, right? So these are dimension tables. Then we are creating also a fact table, right? And giving some references for foreign key as well as for primary keys. Also we are creating, and after creation we will be inserting data into that, right? So, and at the end, you can see we are using some joins to get an entire full table. You can see this is the full table that we will get at the end of whenever we are creating all the joins, right? Then we will find some KPIs like total orders, total revenue. Then we will deep dive in more granular requirements where we will deal with all date functions, right? Quarterly functions, yearly, and then some top 10 functions. So in this particular project, you will be learning so many SQL functions from basic to advanced, right? So you will be learning all almost all the functions over here, and this is a real time and as well as advanced project. And this is a kind of project that you can add actually in your resume. You can add it in your portfolio as well, so that it will be stronger, and it will be visible to many interviewers as well as recruiters, so that your resume will create an impact, and you might land with an interview call, right? And if you're good with explanation, then you might get the job also, right? So in data analysis, always remember SQL is very much important. You cannot skip SQL, right? SQL carries more than 40% of weightage in data analysis. So always remember that whatever you create in Power BI, create in Tableau or Excel or Python or any other data analysis tool in kind of visualization, always remember SQL is the tool which is used for data validation, right? So because initially you will see the data in SQL only in any of the database, right? It might be PostgreSQL, MongoDB, whichever it is, a relational database, right? Whenever you create the visualization, because whatever you create on Tableau or on Power BI, it is garbage in and garbage out, right? Whatever you drag the fields, it will show some results, it will show some values over there. But are those correct? Are those foolproof so that business decisions can be taken? And that is only done by using SQL, right? So double check is done on SQL writing queries and comparing the results so that you will get an exact results over there, right? So this is how it is actually done, and we will be seeing everything in this particular project, how to write and create different I mean to say results as well, how to grab those everything, how to create a document. You can see I have created a Word document of all the queries, right? I will show you how to do this as well. And the data which we'll be using is added in the description of this particular video. And from there you can download it. It's a CSV file. I will also add the Excel file. If possible, you can add Excel file also or import Excel file. In CSV file, there might be some date issues or format issues. So I will add the Excel file. You can copy the entire data and save it as a CSV file, so that it will be in proper date format and all the values are correctly imported in your MS SQL server or MySQL. All right. So now let's move ahead with our problem statement or business requirements. So this is our business requirements. So there are multiple, names, or we can say terminologies used in terms of names. It is also called as problem statement. It might also called as SOW, nothing but statement of work, or simply requirements also, or we can also call it as functional documents. We also called it as FRD, nothing but functional requirement documents. We also called it as BRD, nothing but business requirement documents, right? So from company to company and from client to client, the namings or conventions would change, right? So first thing what we will be doing in this is, first we will import all the data into our MS SQL server. We will create the database, and after that, after we have imported all the data, we have to do some data cleaning and validation, right? So whatever raw table we will be importing into our MS SQL server, we have to check if all the data is been entered correctly, and check if there are any null values in all the columns whichever we are inserting, right? So check if there is any null values or any blank values, right? So similar way, whenever we check null values, we will also have to check any empty string is there or any blank values are there in whatever dimension columns which we will be adding, right? So we have to find out those as well, and if we find out those, we have to report to our data engineering team, or the team which is handling the cleaning of this particular data, right? Then we will also see duplicate detection, nothing but we will identify if there are any duplicate rows available in our data, and if we find those duplicate rows, we will try to remove those duplicate rows from the data, and we will use a row number function. Not required that you should use row number, but I have just added so that you will learn how to use row number. And this is a kind of partitions or some window functions also we might have to use. So this is how we will do some quick data checks and validation if there are any issues in the data, right? Then we will move ahead with our modeling of our data, and nothing but dimensional modeling, where we will create some star schema. So the data which we will have is in the form of single table, right? But we will be exploding that data into multiple tables, because the current table which we have is a very bulky data set, right? So what we will do, we will separate out the categorical or transactional records, and we will divide it into dimensions, and then we will divide it into a fact table, right? At center we will generate a fact table, and surrounding it, one to many joins we will create, where there will be a central fact table, and all over around it will be dimension tables, right? And that is how what we call it as a star schema, right? You might have learned all of this, right? And why dimension modeling is required, so I have added over here that to reduce the redundancy or duplications in the data or repetitive rows in the data, creating dimension modeling or creating star schema, where we will we will, or we can say, we will explode, or we will just take out those values from there, and we will store it into different tables, right? And in the same way, what we have to do is we have to create a date dimension table, right, where it will store all the date information. Then we will also create a location table, where it will store our state, city, and location table. Restaurant information, all, where it will store all the restaurant names. Categories we will store, where all the cuisine and category will be stored, and the dish names, right? So this all will be stored as an dimension table, and where we will create a central fact table, where it will take all the facts, nothing but prices, ratings, rating counts, orders, all those values, right? And based on this, we have to create some primary keys, as well as we have to create some foreign keys, so that there is a relation in between all these particular tables, right? So this is how we are going to do, and I have generated a sample ARD diagram. So at center you can see this is a fact table, and around that we have created a dimension date table over here, Here is a location table. This is a dish table or name of the dishes, categories table, and the restaurant table. And then we are going to create some primary keys, foreign keys, which will be connecting to all these tables, where we will try to create a star schema over here, right? So this will be a star schema which we will try to generate in SQL, right? We will be creating it in SQL. It's not already available for us. We will be trying to create it in SQL, right? So this will be an advanced part. Then moving ahead, we will have some, insights generation, where first we will do some KPI development. KPI stands for key performance indicator, which is nothing but where we will go ahead and create some high level measures or high level metrics we will find out, which will help business understand that where their business right now stands at, and how they can move or they can go ahead or take it to the next level, right? So this is the summary we can say of the business will be understood by using KPI metrics, right? Then we will so do some deep dive analysis in Tableau or in Power BI. We call it as creation of charts. But here we will do some deep dive analysis, nothing but on based on different categorical or transactional data which we have. We will try to create some insights based on different date based or location based analysis, right? So first we will be doing some date based analysis, where we will try to find out monthly order trends, quarterly order trends, and year wise growth and day of week patterns, right? So this is some date analysis that we'll be doing. Then next we'll be doing some location based analysis, where we will try to find out the top 10 cities by order volume, revenue contribution by different states, right? It will help us understand which location is best performing location and which are the worst performing locations, right? Then we will find out the food performance, right? So on which particular type of cuisine or dish, or we can say different food types, that particular restaurants, the online orders are being placed, right? We will find out top categories, most order dishes, and cuisine performance, right? There's also we'll find out. Then we'll find out customer spending insights also, where we will find out the bucket of customer spend, right? That how many orders they are placing with different price ranges. So that particular range we will find out, and we'll do some rating analysis also for different dish. So how much are 4 star, how many are 5 star, what are the names of those dishes, right? So everything we will be creating and performing the SQL analysis in our MS SQL server, right? So this was all about our business requirement. I will quickly explain you the data which we have over here. So this is the raw data. It is a single file, the Swiggy data that we have, right? And this is a single table, which is a bulky table. If you see, the number of rows we have is 197430 rows. One I will delete it for as a header, and the number of columns we have are 10, right? So based on all of these columns, what we will try to do is we will bifurcate or create different dimension tables and a central fact table, and we will try to create or generate a star schema, where we will properly structure our data and our database, so that it will be easy for reading as well and easy for understanding to customer as well as us as well, right? And based on that we will create few joins, and based on those joins we will try to solve all the business problem that we just saw, right? So all the information that we have is we have a state information over here, so in which state that particular order has been placed, and each row over here tells us the information of one single order that has been placed from the Swiggy app, right? Then once we have state information, then obviously from which city that particular order has been placed from that state, what is the date of order which has been placed, from which restaurant that order has been placed, restaurant we can say. Then location, right? We will deep dive more into the location, and we will see from which particular location it has been ordered, what is the category of that food type which has been ordered, which it is a snack or a North Indian gravy or anything, right? I will just control T and I'll convert. So you can see different values are available, or you can see ice creams or seasonal foods or continental foods or all those kinds of, right, or barbecue foods. And what was the dish name which was been ordered? Multiple dish names are there, right? Paneer and all those. So many dishes are there, right? Then what is the price of that particular dish? Similar way, how many ratings were there on that dish, which are given by different customers, right? So if you see 25 means what? So for this particular dish name, let's say we will consider it as pista, right? Or we can say garlic naan. So garlic naan, it is 98 rupees, 4 star, and 34 people have rated it, right? So in that way, we have this kind of data available over here, and you can see 4 rating is there, but 0 raters are there. So it is an old data which might be stored, but we don't have the ratings which has been performed for that 3 quarters. So don't get confused on how the data is there. Rating is been provided, but it is old ratings, or it is been grabbed from Google reviews or anywhere else, right? And then people will provide more ratings on that, right? So it depends. So the data is structured in that way, right? So this is the raw data which we have, and we will be using the same data, and we will create all the dimension tables and fact tables, as I said, create a star schema, and then solve our business requirements. All right, now we'll move ahead.
So before moving ahead into our video, guys, let me introduce you to my new website. So in this particular website, I have added so many of data analysis material, roadmaps, and the roadmaps which are required for current industry trends, and it will be used for 2025 and 2026 use as well. And edition year is for both. I can say I keep it updating every month. So there are multiple materials available. So you can see I have a data analysis complete material package. Power BI projects are there. You can see Power BI individual projects also, if you want to buy, those are also available. And this is the most unique package where says 30 companies detailed real-time interview question and answer, where it has everything, right? The real-time questions which is been asked in the interview, and the scenario based interview questions as well, both for SQL, Power BI, Excel, data warehouse. Everything is been included for Python as well, right? So you can see Capstone project, which includes all the tools. This is also available. Projects on Tableau, projects on Excel, right? And some other different individual materials are also available on my website, right? And if you see over here, if you look for the data analysis complete material over here, let me explain you what is included in it. So here you will get an data analysis roadmap, right? If you click on this, a complete roadmap is available. If I open this, you can see a complete roadmap is available, and in this there are actually a complete syllabus is available, with links are also available in this. So these links are freely available on YouTube. So with my experience and with my knowledge, I have gathered all the links and created a proper document. So you don't have to pay lakhs of amount in the people who are teaching you, and which will be not 50 or 40% of also what I will be teaching you or I will be giving you over here. It is a complete detailed roadmap with all the tools, right? If you see every roadmap, everything is explained, what you should learn as a beginner and everything, right? So everything is available, all the syllabus with links that you have to learn, right? And these are curated and handpicked by myself. All right, so this is an worth for you. If you go back, there is and detailed other materials. Let's say for Power BI, if I go in Power BI, you can see there are notes available, there are projects also available. So the other separate folder is available for project, each and everything, right? You can see PL300 Power Query, other notes, data cleaning notes, data modeling notes, and all other roadmaps. A special Power BI roadmap is also available over here, guys, right? So also there are some projects available. So you can see Power BI projects. You can see more than 6 to 7 projects are available. Similar for Excel, these projects are available. And in projects, you will get an complete Power BI file. So if you look over here, let's say for hotel management dashboard, you will get a complete data, complete report, a .pbix report, which will be a working report, a working Power BI file, and a problem statement, right? The images used will be also provided to you, right? So you can see the meta ad performance analysis dashboard is also available over here. All right. So if you look more in this particular course, what I am offering for you is, if you look over here, you will also have all other tools data also, right? And in this, I will have providing the practice data sets also. So these are the different practice data sets which you can use actually to create your own projects, right? Then I have also added few real-time industry question answers also, right? So these are the real-time industry question answers, and this is just in September only I have added all these. And it is, if you look for Deloitte, let's say, let's look for other one, right? So let's look for Flipchart. You can see everything is available, SQL questions, and it is everything is explained with answer, right? And these are the real-time questions that are asked in interviews. Similarly way, if you're looking for Power BI projects, everything is available, all the Power BI projects are available, and in this you will get all the PBIX files, right? You can see you will get a PBIX file, all the images, the CSV data file, and the problem statements also. And if you want to see all these projects, you can see I have created my new website over here. And if you go in dashboards, right, and here all those Power BI dashboard, Tableau dashboard, Excel dashboard I will add soon. And all this dashboard, if you click on view all, or if you want to see any of the dashboard, let's say you want to see IPL analysis, if you click on this, and it is a workable dashboard, guys. So it will take some time to open, and if you change the season, if you can see all the values are changing, right? So in this way all the dashboards are added. If you want to check what dashboards you will be getting in those 25 Power BI projects, you will actually be able to see on my website. So both the links I will add in the description box. This website link also, you can jump from here also, this particular website. If you click on start learning, you will be redirected to this particular website from where all the packages are available, right? And if you look over here, guys, you can see 4,000, more than 4,400 people have already bought it. And there are so many messages I have received that they actually, the projects are very good, actually the material is very good. So it is proven, it is not fake, it is a real time, everything is real time. I am not doing a scam over here. If you are in doubt, you can reach out to me to my email and or a WhatsApp number which is available in the description of this particular video, and you can go through this website. I will add the link in the description box, and if you like it, you can buy it. If you don't like it, you can just go ahead with the video and see the entire project or whatever I am teaching you. All right, so now let's move ahead with our video.
Alright guys, now so I will just open my SQL server. So this is SSMS. So you just have to type SSMS. And if you don't have MS SQL server, you can install it from their official website. You can download it. And obviously there are multiple videos available on YouTube which you can follow and install the MS SQL server. And as I told, you can use any database. You just have to import the data, and few changes in the queries might be there. If you are not able to do it, just paste the query and ask Google to how to change this MS SQL server query to MySQL server, right? You will be able to do it, right? So I'll just click on connect. So this is my MS SQL server. I'm using a older version, but it will be working in all the versions. So when you open your MS SQL server, at the left hand navigation, you can see the Object Explorer window or pane is there, where you have different multiple folders available over here. And the first one is database, which is required for us. So when I open this database, here there are multiple database which I have already worked on. So those list you will be seeing over here, and I already have the Swiggy database also, but I won't be using that. I will just show you how to do it from the basic start. Everything we will be doing, right? So before importing all the data that we have, the first thing that we have to do is we have to import all the data first. So for that, what I will do, I will just right click over here, and first we'll create the database. So I'll just after right click, you will have an option here called new database. And remember that you can also create a database using a SQL query, but if you have some UI functions that allows you to create a new database, then why to use those, right? So I'll just create a new database, and it will be asking you a name of the database, right? So I will name it as Swiggy database, right? You can give any name, whatever you want. I will be using a Swiggy database. You don't have to use anything, the rows or whatever database files, and the limit is their size limit. That is enough for us to import our data. All right. Then I'll just click on OK. Then it will execute, and you can see a new database over here, that is Swiggy database has been created. Now when I click on this plus button, it will expand, and you can see the files or the folders which are available inside this Swiggy database. All right. So there are some database diagrams over here, and I don't think so we will need those, but we want tables. So when I expand tables, And right now there are no tables which are been imported. At the bottom you will see all the table names. So if you see over here, when I import expand this Swiggy database which I created originally, and if I expand these tables, you can see there are different tables available over here, the dimension tables and the fact tables, right? So I will just close this, and this is the newly database which I have created. Now once the database has been created, the next task is to add all the files in it, or import all the data in it, right? Whatever we have. So for that, what I will do, I will just create on the name of the database. I will right click over here, and we have an option called tasks, and in task you have to go down, and you have an option here called import from flat file. So whatever data we will be importing, it will be from CSV file only, right? So make sure you have a CSV file, a comma separated value file. So I will just click on import flat file. So a new dialog box, a wizard window will be opened, import file window, where you will be importing all the files. So I'll just click on next. Right now you have to browse your file wherever it has been saved in your system. So the file which I have attached in the description of this video, you have to download it. You have to save it in your folder in your local system, and then you have to browse it from here, right? So I'll just click on browse, and this is the data which I have, right? So Swiggy CSV file. So I'll just click on open, and you can see it has taken the path of the file from my local system. Then I have the table name, so it is asking us what should be the name of the table that you want to add. So Swiggy data is the table name I want to add, but I want to change it to small alphabets, right? So I will name it as small alphabets, right? So the schema which will be used, it will be a DBO, is nothing but database object. DBO stands for database object. It's a database object, right? Then I'll just click on next. So it is saying that it cannot be opened because it is been used in another application. Why? Because it has been opened in my Excel file over here. So that's the reason it is unable to import the data. I will close this from here. I will click on don't save. I will click on OK. And now it has been not opened anywhere in my system. Now I'll just click next, and now you can see you will get some top 50 rows. You can see top 50 rows are available, and it is asking us if everything is correct or not. It is asking us that some column names are being changed due to invalid characters, and this is the name which has been changed, nothing but price, right? If you check the original data set, it is in brackets, and wherever you see a space in between them, it will be stored by an underscore. So that's the only difference which has been taken, right? Then we'll just click on next, and here there are this is the columns which has been generated, and automatically there are the database, we can see a data types are been taken over here based on whatever values are being stored in these columns. SQL server identifies what should be the data type given to those. So you check it, you can see state is been given as nchar or nvarchar 50, which is okay, right? Which is fine. Varchar or nvarchar is fine. You just check that order date is been given as a date data type. This is very important. If you download your CSV file, and if you check whenever you are importing, there might be some changes in your CSV file when you download with the link which I have provided, and it might be changed over here. It might You might be seeing a text day field over here, and whenever we will be performing date calculation in our business requirements going forward, you will get an error, right? So make sure it is a date data type. Whatever measures we have, if it is in a decimal, it's a float, that is fine. Rating count is a small integer because it's a small value, right? The proper whole number is there, that's the reason it's a small integer, right? Then just click next, right, and click on finish. So once it is there, you can see operation has been failed, and you can just click on error, and here you can see what is the error we are saying. You can see this is the combo for botis, wheel, onion, garlic, and all this string cannot be converted to type when error care for column 6. That is nothing for dish name. It is saying it cannot be used as an nvarchar for the dish name, right? I'll just close this, and I will just try to open the dish name over here. So I'll just try to open our data, and when I open it, I will just expand it, Okay, and if you see the dish name, you can see the values are very large, right? And there are multiple bin characters also been used, and it is a very large stored value. So we have to make some changes. So I'll just close this and I will click on don't save. I will come back to over here in import data, and I will just go previous, and here it is saying for dish name. So I will change this to varchar. I will use varchar 50, and what is 50 means over here is it can store 50 characters or fill 50 alpha numerical values in that particular column. So there might be case that some of the dish names might be exceeding more than 50. So what we will change it to 150. And you can give any higher number. Similar way, what we will do, we will change the name of state and all of them to varchar. Just change it to varchar 150 itself, right? It's not required for all of those, as characters of state and restaurant name won't be 150, but it's safe side, just do it. It will not create any harm to us, right? So now you can see we have changed everything to varchar 150 wherever you see and varchar. I'll just click on next and I'll click on finish. Now you can see it is loading. It will take some time and we are getting again an error. And when I check, and you can see invalid column length for uh, COLID 7, right? So let's check what is there. Go back, go back, right? So it's for dish name again, I guess 1, 2, 3, 4, 5, 6, 7. Yeah. So what we'll do, we'll change it to more, we'll change it to 200, right? I'll just click on next and I'll just click on finish. So now you can see the length was smaller. I mean, 150 character was also a smaller length for us. And you can see we have got a success, and you can see following task has been completed and all our data has been now brought into our database. And I'll just close this. And right now you cannot see anywhere that data. So to see that, what I will do, I'll just right click and I'll just refresh it, right? So once you refresh it, and I will just open our tables, and now here you can see the database object Swiggy data, the file has been imported. Now how to query that file? So for that, what I will do, select our database in which that file has been inserted, right click and click on new query. As soon as you do, a new query window will be generated over here where you can actually write the queries over here, right? So now let's see how the data looks. I'll just fire a statement, select star. Star is nothing but it will select everything from that database object which we have imported, and we will be able to see all the data. Select from the name of this table. We have to add the name of this table, nothing but Swiggy, right? So this is the Swiggy data, right? And now just select this, or we can yeah, it is good practice, select this and just execute, right? I'll just click on execute. You have an execute button over here, and you can see all the data has been there, right? All the data has been brought over here, and you can see that it has been correct and properly available for us perfectly. Getting? So this is how the data has been imported. And now next we will start doing our business requirements. And the first what we have to do is we have to do some data cleaning and validation, data checks with our data before we proceed ahead. Alright guys, now we will move ahead with our first requirement, and as per that, what we have to do over here is we have to do some data cleaning and validation. So for that I will just add a comment, so it will be easy for us that we know what the queries are for. So this is first as data validation and cleaning. Okay. So first what we have to do is, as per this, we have to do the null checks, right? So we have to find out if there are any null values in all of the fields whichever we have. So at the bottom you can see I have run this query and there are multiple fields which were there in the data. So we will do all the null checks and the data quality checks, and we will see if there are any null values in this. All right. So we have used a long query. So I'll just paste it the query first, and it's very easy. I will just tell you what's the meaning of that particular query which we are using over here. So what I'm using is a select statement, and after that select statement, I'm using a one more function or one more long statement inside it. And what does it represent is we I will just mention the internal query which I have written, case, right? So we are writing a case statement and we are using a when statement, right? Case when state, right? So we have a field called state over here is null, right? Is it means that it is checking if it is null or not. Then if it is null, then give the value as 1, and if it is not null, then give the value as 0 and end. So this is a if statement or a case statement, we call it in another language. So that is the statement which we have written over here, and we will name this entire column in SQL to be given as a temporary name as null state, right? So in this way, what we have done, we have used comma over here, and we have did it for all the fields are available. You can see city we have written, and we are using order date, restaurant name, location, category, dish name, price, rating, and rating count. We are checking it for entire data we have. And what we are doing is we are taking outside as sum. Why we are taking is, if let's say state have few null values, then it will return as 1. So let's say there are two values, then it will return 2 times 1. Then output should be take the sum of how many times the 1 has been returned through this statement. So if it is returning 2 times, then sum means what, it will give the output as 2, right? So in that way you can use count also, but whatever you want, right? We can use whichever will take the occurrence of repetition. Count will be also used, sum can be also used, right? So both of them, anyone can be used. Distinct count we cannot use because one will be written multiple times, so distinct count will be one, right? You cannot use max or minimum, so sum or count you can use. So when I run this entire query and when I execute it, so you can see for all the values which are the names which we have passed over here, we are getting the return output as 0. So what is the meaning of this? That there are no null values available in our data, right? So what we have written here, if it is null, then give as 1. If it is, I mean, this condition is failing that it is not null, then it will return as 0. And you are getting everywhere 0. It means that there are no null values available in our data, which is a good point, right? So if you are getting anywhere any values over here, let's say 1 is there here or 2 is there, it means what, that there are one null value or one null value in this restaurant column, or two null values in category column. So it is always recommended that you should get a 0, unless and until the data or the business itself have a demand that few of its columns should have a value as 0 or null values. And if it is returning over here, that is fine. But if only that particular business case demands, then only. All right. So I hope you have understood what we have written, and how to check the null values, right? So query was long, that's the reason I just pasted it. So this is how you write it, right? Then next we have to move ahead and we have to do some other data quality checks, right? So we will find out the blank strings or blank data, that is nothing but blank or empty string. So I'll just copy this and I'll paste it over here. So next what we have to check is for the empty string. So I will write a query over here. So I will use a select statement. We have to return everything. I will write the query and I will explain you what's the meaning of that. So select everything from what, from Swiggy data. Okay, so this is the name of the table that we have, and we will use a where condition where state. So we'll use each and every column we have. That is nothing but first we'll use state. Nothing but state if it is equal to blank, right? So if you are writing this, this means what? If there are any blank values in our state, then return it, right? Or, okay, we have to check it for city also, right? So if city is equal to same, if it is blank, okay. Or we have to use multiple condition. We have to check for restaurant name also. So if restaurant name is equal to blank, and we have to do it for all dimension values. So I'll just select this and I will run this. So wherever you see dimension values, we have to check it, right? So we have checked for restaurant, then we will check it for location also, right? If location is equal to blank, or after that we'll check it for category. Okay, if category is equal to blank, or we'll check it for dish name. If dish name is equal to blank, I will take it to next line. Or we will check it for rating also. You can check it for rating also. So first we'll check it for price. Okay, price is equal to blank, or check it for ratings also. So we'll check for rating also if it is equal to blank, or we can check it for rating count also. right? If this is also equal to blank, right? So this is what we have to check, and I will just run this, right? So when I run this particular query, you can see we are getting all the records in this. So what we have to actually check over here is just give me if there are any blanks over here, right? Okay, so now we are getting all the results over here, and this is not expected. The reason being over here is that we cannot check it for this particular query. It cannot be checked for major values, right? We have to just check it for all the dimension values like state, city, not order date as well, restaurant location, category, and dish names. For those only, we have to check empty strings, right? So we'll remove it from here, the major values, and now I will run this query, right? And if you run this, you can see we are getting we have selected give all of those fields, or we can say and return all the table if any of these dimensions wherever you are saying if they have any blank values in it, right? And when I run this query, you can see you are getting a no output. It means that in none of this particular fields, this dimension fields, there is a blank value available, right? So this is how you do the blank check. Alright guys, so now we will move forward, and as per our problem statement, we have to check the duplicate detection. That is, we have to check if there are any duplicate records available in our data. So for that, I will just write a query. So I will just write the query and then I will explain you. So first I will run this entire data we have. And now we have to check the duplications for entire data that we have. Not only for dimensions, we did the blank check for only dimensions. So here what we will do, we will check it for all the entire set of rows if we have, right? So for that, what I will do, I will take all the fields one by one. So I will take the state field first. Okay, so we'll just take state. Okay, we'll use a state field. Then also I will use a city field. Okay, comma. Then we have to also take the order date field. Okay, we have taken order date. Then we have to check the restaurant name also. Okay, okay, restaurant name. Then we will check it for location as well. Okay, so we have to select all of this. Then we will also check it for category. Okay, then we will check it for dish name, comma. Then we will also check it for price, INR, and we will also check it for rating, and we'll also for rating count, right? And we have to take it from also. Now what we have to do here is extra thing that we have to take count. Okay, so we have to count all of this. If it is more than one, then return that count so that we will get as, and I will name that as a temporary name as count. And from, I want everything from Swiggy data. Okay, and we have to group by. Why we have to group by? Because we are using an aggregation over here. So always remember, whenever you are using any aggregation, sum, count, max, minimum, average, whatever fields are being brought in to the query, we have to group all of the fields, or we have to group based on all of those fields, right? So that is a compulsory thing, right? We have to group them because you are creating an aggregation in your query, right? So we will group by, and we will use a having clause. If all of these fields are returning multiple values or same multiple values, then, and we are taking a count at end, right? So if the count is 1 2, if it is greater than 1, then we have to return those rows, right? So we'll take having count of star as greater than 1, right? So this is the condition that we want, and I will run this query, right? So it will be executing, and here you are getting, you can see all the values over here, and at the end you are seeing the count as 2 everywhere, right? So you can see count of 2 is available everywhere over here. So what does it mean? That there are 29 records which are duplicates, right? So you can see if this first record, it is multiple, or we can say it is 2 times available in our data, and you are getting a count f2 because whatever is greater than 1, if it is equal to 1, that is it is available only once in our data, so it does not have any duplicates, right? But if it is greater than 1, that is occurring 2 times or 3 times or 4 times, so then duplicates of each row of that, or we can say duplicate of that complete row, is available in our data. And that is what we have to avoid, or we have to delete that duplications in our data, right? So we have identified the duplications, now we have to delete those duplications, right? So we are going to delete the duplication, but we have to only delete the one occurrence of it, right? So we cannot delete the entire 29 records which are occurring 2 times. We have to just delete, if let's say it is occurring 2 times, out of two only one occurrence we have to delete. So for that we have to write the query over here. So I'll just write the query and I will explain you how it works. So we use a with function over here. So with city, so city will it is nothing but a table expression which will create an temporary table or create a table for us, and based on that we will write the query, right? So as I will create an open bracket, right, and I will write the statement over here as select star. Okay, we want, I want select star everything, and I will use a row number function, right? So I'll use a row number function. Row number function is nothing but it will give the numbers to the whatever a table which we are bringing, that is ct table which we will be creating. It will give row number to each and every row for that particular city expression, right, or a table, right? And I will open and close the parenthesis, and I will use a function called over, right? So this is also a kind of a window function, right? And I will use a partition function with it, right? Partition by, I want it by state. Okay, so all of fields, right? So which all fields we have used over here, so we'll use all of these fields. Control C, and I will paste it over here, so it will reduce our time of writing. So everything we are using, and I will use order by select null. Okay, so what does this do is select null is nothing but whatever row number which we are writing over here, it will order with respect to that row number whichever we are getting, right? Then I will close this bracket, right, and I will name this entire, which is nothing but a temporary table which we are creating in our query. I will name this as, let's say, rn. Okay, and from Swiggy data, right, we want everything from Swiggy data. I will close this parenthesis, that is for table expression, and then I will use a delete function, right? So I will delete from CTE, right? So I will delete from CTE where, okay, where if RN is what, if this is getting an, or we can see this row number whichever we are getting over here, if it is greater than 1, right? So this is the query which we are writing, and I'll execute it. So it tells us that we are getting an error, so it should not be comma over here. So it comes with row number over function, it comes with one way. It is nothing but we are getting a syntax error at row number. So now I will run this and I will execute this. So it will take some time, and you can see that those 29 rows which were there, those are now affected, right? And only one occurrence has been affected, because whichever are having row number as greater than 1, those only will be deleted, right? So what it will do, it will give the number as 1, 2, 3, 4, likewise, right? So if it is repeating, the one number will be given to the first occurrence, and two number will be given to the second occurrence of that entire row, that is duplication row. So it will only delete those rows which is having the occurrence greater than 1. So it will keep the first occurrence, and whatever the second occurrence is there, it will delete everything. And you can see 29 rows are affected with respect to that. Getting? So this is how you delete the entire duplications, right? And if you look at the next thing, that is we have used the row number function and we have removed the duplicates, right? So I will name this as we can see delete the duplication or remove a duplication, one and the same. Now next what we have to do is we have to start our actual designing of our star schema. Nothing but we have to create the dimension tables, and based on that we have also have the ARD diagram. So this is what we have to create now. All right. So I hope you have came at this point, and I'm sure you're doing good and you're learning some new things in our SQL project. Alright guys, so now I will move ahead, and based on our problem statement, as I mentioned, we have to create a schema, right? So nothing but the data which we have to break it into four dimension tables, as I already told. And why we do that, you can read this, because in whenever we have the entire table, let's say the table which we have over here. So this is the table, the CSV file. I'll just show you. So this is a very big table whichever we have over here. So it is having multiple dimension fields, and there are facts available, or we can say some transactional values are also available. And what we are going to do is we are going to separate out the locations information, the orders date information, restaurant name information, category information, and dish name information, and all the fact information as in other table. So we are going to create total four dimension tables and one central fact table, and we will try to create a fact table. So sometimes you get a requirement. What we are doing over here is we are reducing the redundancy in the data. That is nothing but we are denormalizing, or we can say we are doing some normalization of the data, not denormalization. We are doing normalization of the data, where we are breaking a single table into multiple dimension tables, where all the dimension, or we can say transactional information, will be stored separate, and the the whatever here you can see a dimension table information, where all categorical information will be stored in different tables, right? So that is what we have to do now. So as I told you, we will first, I'll just name this as creating schema. Okay, so we are going to create schema, and first we'll create a date table, right? So I'll just create a date table first, which will be our first dimension table, right? So first I will also name it as creating dimension tables or dimension tables. All right. So we are going to create a date table over here. So for that we will create a table artificially. So I will name it as create okay table. So I'm creating a table, so I have to name what should be the name of the table. So I will name it as dim underscore date. Dim is nothing but a dimension table, and the name of the table is date, right? I will open the bracket, and now we have to specify the fields which should be there in the table, right? So first field I want is date ID. Okay, so why I'm creating a date ID over here, because this will be my primary key in this particular table, and this primary key will be used to join with our facts table, right, which we will be creating in few minutes. So always create a relationship in between the dimension tables and the fact tables, right? So the date ID will be our joining field, and so I have specified the name of the field or name of the column in our date table which we are going to create, that is dim date. And now we have to specify what should be the data type of that. So I'll name it as int. So what we are going to do is, for this date ID we are going to give the number as 1 2 3 4 likewise, right? So each row will have a unique value. So to have each row an unique value, we have to specify that. Nothing but I am going to use a identify function over here, and I will name it why we are using it. So identify, what does identify do over here is, it will just, I will write 1 comma 1 over here first, right? So now what identify does for us is, whatever row number will be given, so first row will be given as 1, so it will be starting with 1, and this next one is used to give an increment in the given number. So first will be given 1, okay, starting with 1. Then what will be the second value in this one? Add this one, so it will give 2, right? Now in this 2 add one more 1, then it will give 3. So likewise the row numbering will be given 1 2 3 likewise, right? So I hope you're understanding. And this should be specified as primary key, and so I'll name it as primary key. So what does this mean? That uh, this data ID will have, or will be used as a primary key, and we know what is a primary key characteristics, that it should be a unique value on each and every row, and there should be no null values, right? It should not be blank or null, and each row should have a unique value, right? So this is what we want. Then we will add the data in it. So that is nothing but the next column we want is full date, right? And it's so I'll name it as full date, and the data type of this should be as date itself, right? So I want full date, and the data type should be I'll just add underscore over here, so it will not get confused. we want full date, then I want year also. Okay, and for this year I will name it as integer. Why? Because it will be like 2022 or 2025 or likewise, because this is a number, so we will name it as integer. And date is nothing but it will give the date in the format of 1/1/2025, nothing but 1 January 2025, so we want it in a date format. Then I also want a month, same, it will be in integer, nothing but it will give us the number of that month. So just don't forget to add commas, right? Then I want month name as well, right? So I'm also specifying month name and I'm giving it as varchar. Okay, so I will give it as varchar and 20 as a character length, right? Nothing but 20 alphabet would be stored in this month name. So I will name it as month and this name as small. Okay, month name. Then I also want quarter. Okay, so here also we'll name it as year, this also as month, and this as well as full date. Okay, then we want quarter also, name same, it will be in integer, right? Then I also want day. Okay, on what is the day, again it will be integer. Okay, then we want week number. Okay, here also you'll get day number, here you'll get week number, and I will close the parenthesis, right? And I will just run this. Okay, so it is giving us an incorrect syntax, identify. So let me check if it is correct function I'm using or not. Let me check once. Should be correct. It should be identity, sorry. Okay, so this is the identity function that we are going to use. Identity function is used to give the numbering to over here. It's not identify, it's identity, sorry. So now I'll just run this and I will execute this. So it is still saying quarter. Okay, we have to use commas over here. Don't forget to give commas, and now I will run this. And now you can see command has been created successfully. And if you want to see the table which you have created, I will use a select star from dim underscore date. And now here also you are not seeing the data or the table which you have created. So I'll just right click and I will refresh this. And if I see the tables over here, you can see the table has been created, that is dim data. And when I run this table and if I want to see the data inside it, it is blank, right? Why it is blank? Because we haven't inserted any data here over here itself, right? We haven't inserted any data yet, right? We just have created the table, so only structure of the table has been created with its field names. No data has been available over here, right? So this is how you create a date table, right? Now second, what we will do, we will go ahead and create the location table. Now what I will do, I will just copy everything, I will just explain you. So because writing it will take some time for me, and I will explain you because I have explained one table, so I'll just explain the diamond location table now. So in location table, what we are doing is we are creating a table again. The name of the table will be dim underscore location. We are opening our bracket. First field I will always be a location ID, whichever dimension table you are creating. Then its data type will be integer. Identity 1, 1. Why we are? I already told you why we are doing this, because it will start from 1 and give an increment to each and every row, and it will be a primary key, right? Then we are we are adding here as a state column, right? Because if you see over here, if I run the entire query, you can see I'm storing city, city, state, and location. This all the information I'm storing over here, right? In one single table, right? That is in locations table. All right. Then state, because it is a text value, then we are giving it as a data type as varchar in bracket 100. Why? Because we want 100 alphabets to be stored in the state column. So Karnataka might have 10 or 13 characters, but we don't want to take risk, so we will take it as 100 characters here. Same way, city varchar 100 and location varchar 200, because all are the text. So because this will be in the numerical format, so it will give int, but all other will be in text format. So we are giving a data type as varchar, and I will run this table. As soon as you do, you can see command is successfully there. We'll refresh our database over here. And when I expand this, you can see all the table has been created, right? Team location, right? So in this way, We created the locations table. Same way we'll create a restaurants table also. So I'll just run this query, right? Now for locations table, restaurant table, if you see over here, we are having a restaurant name information we are bringing, right? So just one field we are bringing in this table, and the same way we have to create the table. The name of the table is a restaurant, and we are adding restaurant ID because we have to create a primary key to have joining information with our fact table. Same integer identity 1 comma 1, it is a primary key, and one field we are adding, that is restaurant name. And again restaurant name is it is a text data type, so we are using varchar, and the number of fields or alphabets stored or characters stored would be 200 because it's a long name, right? And now we'll run this query. You can see it is successfully created. Similar way what we will do, we will create it for category as well, right? So I'll just copy this and we'll bring it down so we can run it from here. Okay, now what we are doing is categoricals. We are separating out all the category information. Same way again, dim category is the name of the table, and category ID we are naming, and category, because it is a text field, again we are using that. So I'll just run this query and you can see it is successfully there. Similar way, then if I run the entire table again, now we are dish name. So we want the information of dish name as well separated. So for that we will run this particular query. So this is dish name. So it is throwing us an error near comma. Yeah, so we have to close this bracket. Okay, and now I'll just run this. Okay, you can see it is running successfully. Alright, so we have created all the dimension tables. So I'll just right click over here on database and I will refresh it. Okay, and when I go to tables, here you can see all the tables are been created, all the dimension tables, 5 dimension tables we have created. All right, you can run the query to see all the dimension tables. You will just see the structure, you won't see any data in that, right? The next what we have to do is we have to create fact table, right? So next task is to create the fact table, and for that I will again copy the query. It's a long query, so I'll just explain you why what we are writing over here. So I'll paste it. And now, so this is the query to create a fact table. So we are creating a table. Name of the table is fact Swiggy orders. Opening the brackets, and here we are first will be order ID. So for this entire fact table, there will be an order ID table which will be working as a primary key. And same we are using an identity. Then in that what we are adding different other tables over here, that is nothing but date ID. Okay, because we will need it to join it with our date ID over here, right? With the date table, right? So we have created date ID with the integer format. Then obviously we need to add the fact table. So I'll just run this. So all this factual information, right? Price, rating, and count. So that will be available for us, right? So we are using a decimal as a data type for it because it is having a decimals over here, right? And 10 is nothing but it can take 10 values in it, and 2 is nothing but number of decimal after that, right? Similarly, rating 4 comma 2 decimal as an it's data type, and rating count is nothing but it's a simple integer value because we don't have a fractional or decimal points value in it. Then again location ID for locations table, restaurant ID for restaurants table, category ID for category table, and dish ID for dish table. So this will be should be created in our fact table because we have to create a relationship in between these tables, right? If you see over here in our ERD, so this is the ERD. We have to create a foreign key for that, right? So that is the reason we have created over here. And then for each and every table we have to create a foreign key, right? So foreign key with date ID, and we have to give the references of this with dimension date table, and which column field, that is nothing but date ID. Similar way we have to create foreign key, that is nothing but location ID will our be foreign key, and its references should be joined, or it's there should be a relationship with location table, and in location table its references should be stored in location ID. So I hope you are understanding, right? So same field Same field will be used over here, but this field has been created. This field and this field are same. This is the fields that we are giving references so that it is having a relationship with our fact table. Now I'm running this and I will execute this, and you can see it is successfully run. And now I will refresh this table. Okay. And I will just see the tables, and you can see the fact table will be also created, that is this. And if you want to run this query and see the data inside the fact table, select star from fact, right? And I will run this. You can see order ID, date ID, price, rating, rating count. These are the three transactional or major values which we want. Location ID and all other ID columns, right? So order ID is nothing but it will be primary key of fact table. Date ID is the foreign key which you'll use to join with date table. And location ID will be a foreign key which we generated to join with location table. Restaurant ID is a foreign key generated to join with restaurant table. Category ID is a foreign key used to join to category table, and dish ID is used to join with a dish name table, right? So this is how we created. Now we have created all the structure of the table. Next, what we have to do is we have to go ahead and add or insert the data into all of these tables. So for that, we will insert data in tables, right? Because right now the tables are blank, right? We don't have data in those. So for that, I'll just use the query directly. So first, I'll just tell you how we do it for dimension date table, right? So this is the date table. Now we have to insert the data into dim data. So because we have created the dim date table, which I already told you, and these are the fields available in it, right? So sequentially I will write all the fields with whatever sequence we have created it, right? So first we will name full date. If you see the date table over here, first field is date ID. So it will be automatically populated by using this identity field, so we don't have to populate it separately. So we are starting it from full date. We don't have to start with the ID field because it will be automatically populated by using identity field, right? Whenever this data will be entered, the identity field will work. It will do it works and give this each and every numberings, right? Then we have year, month, month name, quarter, day, and week. So these were the fields which we added. Select a distinct, right? So we are selecting distinct values from order date, right? So this is the order date is the field available in our Swiggy data, right? So if I run this, so this is the order date field available, and from this order date field we are going to insert the table in this particular, or insert the data in this table. So first it order date. Then what we want to find out is order date is nothing but full date is nothing but it should be taken as order date, right? So sequentially whatever fields we are seeing over here, by using select this clause we have to add all these fields over here. So order date same will be filled in full date. Then we want year. So year is nothing but what we will take year of order date, so it will get take 2025 from here. Then we want month, so we will add a month of order date, so it will give the month, that is 6 month 4 5 1, likewise the number. Then we want month name, so for that we are going to use date name function, and month and order date. So date name will give return the name of that month, right? Then we want quarter. We are using a date part function because we do not have a quarter functions directly available in MS SQL server. So we are using a date part function. Date part function will return integer as an output, quarter and order date. Then we have day. Day of order date, it will give us the number of that date. And for week number, again we will use a date part function. Week and order date, it will return the number of week from that particular date. From which data we have to bring all the information from the original first information which we have stored, right? All information which is stored from this table, we are bringing it from data where order date is not null. So this is required because we already checked if there are any null values in the data and it is not there. So we just have to check that order date should not be null, right? So this is the condition that we have to do, that if it is not null, then only we have to insert the data inside over here, right? So all values wherever you will see not null, proper value is there, then only the data would be inserted. Now we'll run this particular query, and you can see 243 rows are affected. Now the data has been brought in our dimension table, and now we will see if it is brought correctly or not. Select star from dimension dot date, and I will run this and I will execute this, and you can see now the data has been inserted and automatically the date ID is doing its works using identity function. Each row will be given an incremental number, right? And it is unique for each and every row. Full date is been brought, year of this, that is 2025, is brought over here. Similar way, you can see the name of number of the month is 4, name of the month is April, quarter is second, day is 7th, you can see 7, the week which this particular date falls is 15th week, right? So this is all the date information we have created. Similar way, what we have to do is we have to go ahead and create our locations table, also insert data into our locations table. So what we are doing is insert into location. So these were the fields we want. ID will be automatically populated as I told. Select the distinct, right? So we will be entering all the data from this table, right? So from this state table, will take the data from this state, city will take from this city table, and location will be taking from this locations table, right? This, right? And now we'll just run this. Oops, I will just run this query. And you can see rows are being affected. If you want to see, you can see the locations table. When I execute this, you can see all the location information has been brought, right? So in this way, how you do it. Now we'll do it for all other tables. Paste it over here. You can write the query, you can pause the screen and you can write the query, or you can write it your own way also for your because it will take much time for me to write on the screen, so I'm pasting it directly. So we'll bring the data into restaurant table because restaurant name is the field from where we are bringing everything. So I'll just run it. You can see it is affected. Similar way, I will run this, so you can see all the data is being brought in category table, and we'll execute this. So you can see all the data is being brought in dish table, and you can see and run all the queries to see if the data has been actually brought or not. Run all the tables, right? Do it yourself. And now we have to add the data in fact table, right? So this is a long query, so I'll just write everything, control C, and I will paste it over here, right? So this is the query which we are going to write, right? So now what, how the fact table is been brought, right? So fact, this is the table, then date ID, we have to populate date ID, price, rating, rating count, location ID, restaurant ID, category ID, and dish ID, right? Now we are closing the bracket, again we are using a select statement over here, dd.edate id, right? I will explain you what. S dot price, S dot ratings, then dl dot location, dr dot restaurant, dsc, and all this dish id whatever we have to populate from Swiggy data. But what we have to do is the date IDs which are available, right? So you can see dimension ID, dimension date is dd, nothing but this is the temporary name of the table. From this dimension date, this date ID would be brought, and it will be brought from where? From this order date, right? S dot order date, so that it is creating an proper relationship between all the tables. Similar way, DL, nothing but DL dot location ID, because we have to populate all those foreign keys, right? So it will be brought, or it will be joined on what? En that state is equal to yes dot state, right? Yes is nothing but Swiggy data, which is the original data, right? So from original data, we will select the state, and from the created dimension tables, we will use this state. So what will be this help us is to create those foreign keys, right? It is very much important. It is somewhat hard to understand, but once you understand it, it is very much easy, and you'll understand all the concepts. So in this way, you're joining all the the keys, we are generating all the keys from the main table. And now we'll run this entire query, and I'll just execute it, and it will take some time to run all the query, and you will get a message that it has been ran successfully. You can see this number of rows are being inserted and it is ran successfully. And you can, if you want, you can check it. Select star from fact, okay, and I'll run this, and you can see all the IDs. You can see IDs are generated. So these IDs will be used to join to the dimension tables. All right. Now what I will do, I want to see the entire table in one go, right? So for that, what I will do, I will use select star. Okay. Now what we have to do is we have to create a join over here, right? So this is the joining condition. I'll just copy it. Okay, so this is the join actually, how it works. So I'm creating select star from fact tables, right? The facts table, I'll name it as F. It will be using join. It is nothing but an inner join. If I'm only writing join, it is by default inner join. Okay, dimension date D, I'm joining it on dimension date D. If you see the diagram over here, the main table, I'm joining it to date table, right? On F dot date ID, right? In F, you can see date ID is there, is equal to D dot date ID. In date table also we have date ID. So this is a foreign key, this is a primary key, we are joining it. Then we are again joining it on location L, F dot location ID, nothing but in fact table we have location ID is equal to L dot location ID. Similar way on restaurant, F dot restaurant ID is equal to R dot restaurant ID. We have this as a primary key, this as a foreign key. Category, similar way we have F dot category ID and C dot category ID is available in our as a primary key in our dimension table. This is from fact table. Similarly on dish ID. And when I run this entire query, so you can see we are getting an one complete table, right? All the information, order information, ID information, everything is available over here. You're getting or not? So this is our final table. Whenever you are using joins, this is the final table which we have got. And now using this particular table, what we are going to do, this created, this is the schema what we required, right? This is the schema now generated, and based on this schema now we are going to solve our business problems, right? So until this moment we were just doing our data cleaning, data preparations. So always remember, in real time also 70% of work you will be spending to create or do data preparation itself. Getting? So I hope you have learned something advanced, new functions as well. Alright guys, so now we will move ahead with our requirements. So first we will do the KPIs. Okay. And as per our problem statement, what we have to do is we have to find out the KPIs, total orders, total revenue in million, average dish price, and average ratings, right? So first we will find out total orders, right? So now we already have the fact table. So if I'll run the fact table over here, and if you see the data in this, you can see order ID field is there. So each and every row have a unique value. So each row will give us an information of one order. Second row will give us the information of second order. So in that way, total order is nothing but we can take count of a star, or we can say count of order ID also, whatever you want. And that will be our KPI, that is nothing but total orders, right? So what we will do, and now whatever we will be writing, right? We will be writing or bringing up the data from fact tables and dimension tables. We will be not using the main Swiggy table now, right? So I will use select, okay, count of star. I will use count of star from, okay, or I will name it as what, total orders. I'll name it as total orders from what, fact Swiggy, right? Simple. And I will just run this. Okay, so now this is our what, total orders. Simple, right? So this is our first KPI. Next we will move forward. These are our total orders. Then we have to find out revenue. Okay, so copy this and I'll paste it over here. Right. So now we have to find out total revenue. And for that we will be writing the query as select. Now we have to find out revenue, nothing but if I run the fact Swiggy table. Okay, so now we have to find out the price. So you can see price field is available. So we have to take sum of price, which will give us the revenue. So I'll take sum of price, sum of price underscore INR. Okay, from fact, right? And I will run this. So you can see this is the sum, and I will name it as revenue, total revenue, and I will run this. So you can see we are getting the total revenue, but it is a very long value, and we have to convert it into INR million, that is in Indian national rupees as million. So for that we will do some adjustment over here. What we will do, we will convert this to have and decimal points up to two decimal points and convert it into as to write into a we can say as an INR million. So I will use a format function for that. So here I will use a format function, right? And in sum also, what I will do, instead of this sum, I will write here convert. Okay, I will convert this into a data type called float. Nothing but what we are doing over here is sometimes whenever we are writing the sum of anything, it will give us as a text as an output. And if it is a text as an output, even though it is a number, format won't work. So we will write convert function, and convert will take agreement between what data type we have to convert. So I am converted it into a float. And what we have to convert right now, we have to take sum, right? So sum of what? Price underscore INR, right? And I will close this bracket, and I will close the sum, we can say float bracket, and we are closing the float bracket also, right? Now I will divide this entire thing, right? Divide this entire thing by 1 million. That is by 1 million, so that we can get an units as 1 million, or we can say, and or we can say whatever we can write as INR million. So for that we have to divide it by million, right? And I will write here as N2. Okay, now I will close this bracket, right? So why we are writing this particular thing is, if you look over here properly, that what we have format function we are using, right? So format function, it will be converting this entire value which we have wrote over here, right? This entire value, what it will do, it will convert this into N2 is nothing but up to 8 decimal points at the end, right? So that's the reason we have written it, right? And we will add plus, okay, and I will add INR million. So this is nothing but it will concatenate with plus INR million, right? And we'll name it as total revenue now, right? And we'll just try to run this. It will not run, it will give us an error. It is an error at, so unclosed quotation mark after string. Okay, so we have to close this mark. Perfect, right? So N2 we have to close as a string now, plus INR million, and when I run this query, you can see I'm getting 53.00 INR million, right? It is converting into the latest decimal point, right? Because float value will give us the perfect value, and at the end it will give us INR. If you want one space, you can add one space over here, and I will run this now. You can see 53 million is the value which we are getting, right? So this is how you find total revenue. Then the same way what we have to find out is, as per problem statement, we have to find out average dish price. So I'll just copy this and I will paste it over here. And same thing we'll use, copy, I will paste it. Instead of sum, what we want here is average, right? Just we don't have to divide it by 1 billion, because we are actually finding the average, right? It won't be in millions. And here instead of INR million, it will be just INR, right? So just this change we have to do. And I have to run this. You can see 268.50 is the average value which we have, the order value. One order which is placed, its average order value is 268 rupees, right? Indian national rupees. Understood? Now next what we have to do is we have to find out average rating. Okay, so now this will be very simple. Select, okay, similar, we have to find out average. We have a ratings column in our data, and from where factory, simple, and I will run this. You can see this is average column or average rating. If you want, you can name it as average rating as a temporary output column name, and run this. You can see this is average rating. So whatever results you are getting here, guys, you have to, let's say for total orders, you have to take screenshot of this. Okay, and I have written a query document over here. So you can see this is a query document. So below that query document, you have to take the snip of the result and you have to paste it over there, so that it will be a proof that whatever output you are getting using this query, so that you can send it to the client, or you can refer it later after 1 year, 2 year, or if your any other colleague is working on this project, he will be getting an idea that after running this query, what was the result expected, if there is any error happening, or in future if there are any enhancements requirement in this project, right? So always take snapshot of project with whatever query you are running. So at the top the query will be there, and below that you have to paste the snapshot of this output. All right, so this is how you do this. Now we will go to granular requirements. That is nothing but we have to go and find out the this requirements, right? So as per our problem statement, we have to deep dive into the analysis, or we can name this also. Okay, so we will deep dive into analysis, and first, as per our problem statement, we have to find out monthly order trends. So I'll name it as monthly order trends. Okay. So what we have to do is we have to find out the monthly orders which are been placed, which is very simple. I will write the query. I will write the select query. Select. Okay. What we have to bring? We have to bring the field names. Now here we have to use some join operation, and we all know that where is the month information stored? It is stored in the dimension date table which we created, right? So we'll use that table. So for that table, we will use an alias as d. Okay, so I'll use d dot year. Okay, d dot year. We want year. I will also add a month. Okay, we already have these columns in our data. So we want month, and I will also add month name. Okay. All right. And I will take count of star because order is nothing but count of star from where? Fact table, right? And I will name it as total orders, right? So we want everything from where? Because we want count of star from where? Fact table, right? So it is named as facts wiki orders. I'll copy it from here, fact, and I will name it as F. And we have to join this with team underscore date table, right? And the joining condition, we already know that in fact table we have f dot date id field. Okay, this should be joined to what? B dot date id field, right? So this is the joining condition, date ids, because if you want the information from both the tables, we have to join those. And now when I run this, okay, so it is giving me an incorrect syntax near dot. So let's find out. Okay, so we have to forget to analyze, we give alias name over here. So we have to give alias over here for this table as D, and I will name it and run this now. Still we have an, so we are still getting an error. So it's at dot. Okay, so here we have to add commas. Okay, silly mistakes, not here. And now we will run this. Okay, so we are getting at star. So we have to add one comma over here also because this is also column name. And now we will run this. Okay. So you can see dim rate here is invalid in the select list because it is not contained in either an aggregate function or a group by function. Oh yeah. So one important mistake what we have done over here is whenever we are writing a count function, whenever we are using an aggregation, we have to group it, right? So we have to group it. So we are learning by our mistakes. So we have to group it what? With all these fields, right? Okay, just remove comma from here, and now I will run this. You can see we are getting an output. See, whenever you are using an you know aggregation count, and we are also bringing some dimensional information in the output table, always remember how these counts are taken. We are, January is repeated in the table, so whatever we are taking January, we are combining it and then we are getting it. So we have to group all those dimensions, and then we have to get an the measures over here in the summation or aggregation format, right? So in this way we have done this. And if you want, you can see with respect to total orders, we can also run the order by function also if you want. I will run the order by function based on count. Okay, and I will run this now. So you can see whichever is the highest count or least count we are getting at top. If you want it into descending, you can add it into descending. So maximum will be at the top, and you can run this. You can see January is the maximum selling. Second is August, then May, July, April. So these are in the descending order with respect to total orders, right? So you can also, if you want with respect to sum, you can also do that. So if you want summation, if I paste it over here, and if you want total revenue, so you can do here what? Sum of price in INR. So price in INR, and this will be what? Your total revenue. So if you want revenue over here, so just sum price of INR, control C, you have to add it over here as well. And I will run this. right? So you can see you will get the value in revenue here also. And if you want to give some this format to this, you can bring it over here also, right? You can give the decimal points and millions to that. So I will keep it up to you. Practice it how to give it. I have already told you how to do it over here, right? In average disk price and as well as over here as well. Divide it by 1000 and you will get that value over here, right? So just try to bring that, copy paste it over here itself and you will get that value over here. And in order by also you have to paste it. All right. So this is how you get by month. Second, what we have is, and problem statement is to all we need it by quarterly trend also, right? So what we will do, we want quarterly trend. Okay. Same, we'll paste it. Okay. I'll just copy this entire thing. Control C. I'll paste it over here. So just instead of this, what we want is we want d dot quarter. Okay. We want it on quarter. Similar way, copy this and here also we have to paste it and we'll run this. So order by, I'll remove order by from here and I'll run this. So we are getting syntax error. Okay, this comma is not required. And I will run this. You can see we are getting with respect to quarter also. And if you want order by, you can use order by, Control C, Control V, and we'll use VSC. And I will run this query. You can see incorrect syntax near count. Why is this incorrect? You have to use order by. Okay, and then VESC in descending order. Right? You can see second quarter is the maximum, then first, and then third. Right? So in this way, you do the quarterly trend as well. Similar way, we will do the yearly trend also. We have to find out yearly trend. So I'll name it as yearly trend. Okay. Just here, few changes would be required, and you can find it for sum of sales also. That is for total revenue. Remove this from here and remove this from here. Okay. Again, those silly mistakes. Let's see what. Select. Okay, so this is only 1 year we have, so we are getting only for 2025 because we have the data right now only for the 1 year, right? Similar way, we have to find it for order of the weeks. I'll just copy this entirely and I will paste it over here. So we have to find out orders by day of week, that is from Monday to Sunday. So only thing what we have to do here is in our dimension date table, if you run this query, we don't have the name of the date, right? So what that's the reason we are using the date name as a function, and in that we are using a weekday. We are starting the weekday from where we have to take rabbit from full date the name as that, and then just that's the only part we have to do over here, right? And we are ordering it by weekday and we are also grouping it by based on the date part value also, right? It is not required over here, but still we are doing it. And when we run this, we are getting all the information from Sunday to Saturday, right? Right, so in this way you will get and information of with respect to day name what are the total orders. We can also get sum of sales also over here. All right. But guys, so now we will move ahead to our next problem statement. And if you look into our problem statement, we have to do location based analysis. We have to find top 10 cities by volume, right? So I will just paste it over here. So this is our top 10 cities we will find out. All right. So first I will write the query over here. So select, okay. What we want is cities, right? And from that what we will use, the city information is stored in location table, right? So I will use L. Okay, so this is L, not 1, it is L dot city. Okay, comma, what we want is count of orders, so we'll take count of star, right, from and we will name it as total orders, total orders from fact table, right? I'll just copy this Control V, and I will name the alias as fact, and I will join it on what? On L dot locations table, or not only on locations, right? The dim locations table, and I will name it as alias as L, and we have to join it, right? So it will be L dot location ID is equal F dot location ID. Okay, so on this we have to join, and I will run this query. When I run this, so it is giving an invalid because we have to use group by, because we are using an aggregation, so we have to group by the value which we are using. Paste and remove the comma. Okay, and I will run this now. You are getting all the cities over here, but what we want is we want just top 10. But using top 10, what we will do, we have to add here as a descending. Okay, we have to order it by descending. So I will order by descending first. Okay, and when I run this query, you can see order by descending based on format. Okay, okay, you can see now we just want top 10 values, right? Up to here we want. We have already added in the, in descending order. Now we want top 10. So what we can do here, you can just add here as top 10, whatever you want, right? So this is top 10 we want, and I will run this query now. Oops. Okay, just add space in between and now run this. You can see you will get top 10. So based on that, you can identify whether you want top 10 or you want top 20, whichever you want, right? In this way. Getting, and if you want bottom 10, right? So if you want bottom 10, so I'll just use this top 10. I'll run this first. So to use bottom 10, you don't have to write your bottom. It will be top 10 only, but just in ascending it is in descending. Here you just mention it as ascending and then run this. And you can see these are the bottom 10, right? Because whenever you are going with ascending order, it will start from minimum and then it will go to maximum. And in descending, it will go from maximum to minimum, right? So now if you want to find it for sum of sales, you just have to change this to sum of sales, or we can find it to price of, we can change F dot price underscore INR. Okay, and this will be what? Total revenue. And we'll just copy this and it will be used here. Paste it and I'll run this. You can see we'll get with respect to INR as well, right? This will be bottom 10. If you want top 10, you have to write here in descending order, right? So this will be your top 10, bottom 10, whichever n values you have to find out, you can get. Right, so this is that, and now next what we have to find out, revenue contribution by states. So this will be very simple. We just have to use state column. So instead of this, I will copy this, paste the query here. We don't want top 10, so I will delete this top 10. And instead of city, what we want state, right? Similar way, we have to change here also to state. And now when I run this query, you can see we are getting all the states from start, right? So you can see the maximum contribution is what with respect to Karnataka, right? This is the maximum contribution, and the minimum is what? Sikkim. So if you want top 10, you can find top 10 also. This will be your top 10. So depending upon what's the requirement. So you can play around. You can also find it for orders. You can change here to orders. You can take the screenshot. You can store it in your result as well. All right. So this is how you find it. Now we have to go to food performance. We have to find out top 10 restaurant by orders. So similar way, I will just copy this, paste it over here. And now we have to find out with respect to restaurants. So I'll just copy this same thing. I will paste it over here. Now we want it restaurants, but we have a restaurant table over here. So instead of this, what we will do, we'll name it as r dot restaurant name. Okay, because we have that field in our data, that is restaurant name. Okay, and instead of this, control C, here also we have to name it as restaurant name, and we have to join it one dim dot restaurant. Okay, on this, and alias as r, and we have to join it on what? R dot restaurant ID. Similar way on f dot restaurant ID. Same, and run this. You can see we are getting the restaurants, and if you want top 10, then you can just name here as top 10. and you have to mention your descending. Don't forget about that. And run this. You can see these are the top 10 restaurants. That is McD, KFC, Pizza Hut, Burger King, Domino's, Lunchbox, The Good Bowls, right? So these are some famous restaurants which are falling in top 10 or top 5, right? So this is how you do it. Then we have to find out top categories, right? Which from which categories they are. So this will be changed somewhat, right? So I will just paste the query as it is because it will be not a very simple query. So it is just simple because we have to use a C dot category because we have to use your category table here. You can see here. That's the only change, and we have to join it on category ID. That's it. And run this. So you can see these are the top recommended. So recommended is nothing but whenever you open a Swiggy app, you get some recommendations over there. So based on that recommendation, you go ahead and place the orders. And recommendations are given based on the ratings and recommended by other customers who are buying the similar orders. So that based on that data, Swiggy will give the recommendation for you, right? So this is how you do by top categories, right? The next we have to find out most ordered dish. So similar way, I'll just copy this. It will save my time. Very easy queries. And once the joining, you know how to do that, it will be very easy. Now we have to find it on most ordered dishes. Similar, nothing but count of orders we have to find out, and we have to join it on dish ID, right? I will run this, and you can see it will take some time to execute the query because the data would be high. So you can see this is the maximum ordered dish, right? So veg fried rice, choco lava cake, jeera rice, and all those, right? If you want to find out top 10, you can find out top 10 also, right? And I will run this. So you will get the top 10 queries, right? So this will be green salad, butter naan, and all those. These are the top selling or top most ordered values, or we can say orders, right? Next, what we have to find out is cuisine performance, right? So cuisine performance, I'll just find out where is. So this is the cuisine performance. Copy, we'll paste it over here. Cuisine performance is nothing but in categories table, we have to find out average rating provided to that and the rate, total orders also. So rating, what we are, why we are using this ratings over here is nothing but to convert the average ratings into float value. If you don't want, you can just remove it. You can just use the simple rating also. If you are getting confused, then you can just run this, right? So you can see recommended. So this is the maximum rating. Okay, and if you want based on rating, instead of this, let's say you want it based on rating over here. So I'll just click on this, or we'll just take Control C. I will paste it over here, and you want it in descending order and run this. So you can see best ratings are given, 5 ratings are given to add and all this, but only one order has been placed to this. So this is not actually helpful for us, right? So we'll just run with total order itself. So based on total orders, you can see what are the ratings given to those foods which are been ordered. Alright. So this is on order ratings. And now we have to find out the customer spending insights, right? So this will be a long query. I will just help you understand, right? So this is the query that we have to find out, and I will run it over here. Okay. So I'll just explain you how it works. I'll just take it a bit down. I'll explain over here. So what we are writing here is we are writing a case statement, and what we have to actually find is, so customer bucket spend is nothing but order value which is under 100, order value which is between 100 to 199, and up to this, right? So in which particular values, or in which particular range the maximum orders are being placed. So we are creating a case statement. We have to write a if condition. So we are writing a case statement when. So convert statement, this is optional. If you want, you can write it. If you don't want, you can remove it, right? So it is just used. If you want, you can remove it. Remove convert, remove float, remove this comma, right? It doesn't matter because already the price value is in that. But it was giving me error when I was doing the project originally. So that's the reason I have wrote over here. You can remove it from here entirely. So if it is less than 100, if price is less than 100, it will be falling under 100. Similar way, if it is in between 100 to 199, then we want this as an output. If it is between 200 to 299, then we want this as an output. Similar way, this. We will end this entire, the columns which we are being going to create. Then we want it from fact, and we will group by this everything because we are using count of star, and we will end it very easy, and we'll run this. You can see we are getting the total values over here, right? In price range 100 to 199, you can see 56,000 orders are there. In 200 to 299, we can say 54,000 orders. And 500 plus, you can see 1609. Under 100, these are the orders, right? So if you want, you don't want this, you can just have a proper range over here, right? So I will just remove the order by and I will just run this. You can see 500 plus and all those, see 100 to 99 and all those, right? So this is how you run this, and you can actually get this. Then you can find out the rating analysis as well. So I'll just run this query on based on how many ratings are being provided, right? So rating distributed between 1 to 5, and I will run this query. You can see the rating counts similar way whatever we have run with here. So how many are given 1.5 rating? So 64. So in this way, if you want, we can name this in descending order, right? So you'll see what are the maximum rating given. So if you want the maximum ratings, we have to use count of star. I will paste it over here and I will run this query. So you can see 4.40 is the maximum rating. 85,000 orders are being given as 4.4 rating. 13,000 are given as 4.3. And if you want the least rating, you can see 1.7 is the only 25 ratings are being given. So the food delivery apps are doing good, hotels are doing good, and customer are happy actually by looking at these stats, right? So these are few business requirements which we have solved over here. I know I have pasted the queries, but it will take so much of time for me to write. And so you can pause the screen actually, and you can write the same query for you, and you can run it. So just write it. I already know how to write all the queries, but you as a beginner, I request you to go and write the queries, because once you write it, read it, and understand and resolve the errors, you will learn most of the things, right? By copy pasting, you will not learn anything. All right. I already did this project once and I'm repeating it over here to you. That's the reason I'm not writing it again and again, and it video will be very much long, and I don't want that. So there are more business requirements which can be created, and you can work on those. You can find yourself what video, what can be created, and you can learn from that as well, right? So this was all for this particular project, and I will see you in the next one. Till then, just go ahead and like, share, and subscribe this particular channel and video as well. See you in the next one, guys. Bye bye.